So my presentation today, the title is Reductions in Biomarkers of Exposure when Switching from Cigarette Smoking to Using a Tobacco Heating Product for 6 months. And just to provide some background, here I show a model for a continuum of relative risk. On the far left, we have cigarettes, which have the highest risk, and the position has been confirmed through epidemiology. On the far right is nicotine replacement therapy, NRT, which is considered safe and is a position confirmed by medical regulators. We have modern oral tobacco products, vapor products here, which are potentially 95% less risky than cigarettes, which is a position proposed by public health authorities. And we have THP, which is one of the newer categories here, tobacco heating products. And part of our program of study for some time has been to contribute to a risk assessment of Gale, which is British American Tobacco's tobacco heating product. British American Tobacco's potentially reduced risk product framework shows the types of studies which can yield data to allow an informed assessment of relative risk. And more detail is available in the publication shown here at the bottom of the slide. We're looking at studies in the areas of preclinical, clinical, and in some cases population level studies. On the right-hand side, I show our progress against this risk assessment framework for the Gale tobacco heating product. As indicated by the green bars, we've completed the majority of these assessments for Gale, with data published in several journals. If we look at the findings from each stage of our risk assessment, moving from the top left, we've seen that the product is stable. Physicochemical characterization has shown significant reductions in chemical toxicants in Gale emissions compared to cigarette smoke. Preclinical assessment included computational toxicology, which showed reduced toxicity in silico with in vitro toxicological assays showing no or substantially reduced responses in mutagenic and cytotoxic endpoints compared to cigarette smoke. Biological responses relevant to disease development were absent or greatly reduced, and our system science showed substantial reductions in cellular perturbations relevant to smoking. Moving to clinical studies, which is the area in which I work, we have data to show that Gale is similar to a cigarette in terms of the nicotine pharmacokinetic profile, and our short-term clinical studies have shown that exposure to cigarette smoke toxicants is greatly reduced in smokers who switch exclusively to Gale for a 5-day period, in many cases to similar levels of exposure as smokers who quit smoking for the same period. And the final 2 boxes show that we've also completed studies in the areas of consumer risk perception and post-market surveillance. The final piece of the jigsaw is clinical data assessing toxicant exposure over a longer period than the 5 days we have thus far, and the effect of the reductions in exposure on relative risk. And this is the aim of our 12-month biomarker clinical study. This is an ambulatory switching study carried out to the international standards of good clinical practice at 4 clinical sites in the United Kingdom. The study was registered on the ISR-CTN Clinical Studies database, and the protocol has been published in full at the reference shown here on the slide. In brief, we recruited 3 separate populations: up to 280 smokers with no intent to quit, with up to 80 of those randomized to continue smoking, and up to 200 to switch to using Gale. We recruited 190 smokers with an intent to quit smoking, and they were supported to do so with nicotine replacement therapy, pharmacological therapy, and smoking cessation counselling. We also enrolled 40 never smokers who continued not to smoke. Subjects attended the clinic approximately every 30 days for 1 whole year, though the never smokers were requested to attend less frequently. And at each visit, we took breath, blood, and urine samples, which were analysed for a range of exposure and effect biomarkers, and physiological questionnaire and safety measures were also performed. Whilst the clinical phase of our study is now complete, my presentation today is focused on the biomarker of exposure results over the first 6 months of the study, visits 1 to 7 as indicated in the red box here. This table provides an overview of the subject numbers. The total enrolled column shows the number of subjects we enrolled into each study arm, with the next column showing our target for the number of compliant completers for the full 12 months. The next two columns shows the numbers completing to the 6-month time point and the number of withdrawals. And the withdrawals include those who either self-withdrew or were withdrawn from the study prior to 6 months for any reason. As you can see, the numbers completing to the 6-month time point look very good. Now, I mentioned compliant completers. For the never smoker and continue to smoke arms, compliance in terms of product use is fairly certain, since we're not asking them to do anything different to normal in that respect. However, in both the glow and cessation study arms, the likelihood of non-compliance with the restriction to not smoke is high in an ambulatory study of this type, and there's a strong possibility that some subjects would not report this non-compliance. So an assessment of compliance with smoking abstinence within the glow and cessation arms was absolutely key in order to avoid potential underreporting of the effects cessation or switching to glow has on the study endpoints. Measures such as exhaled carbon monoxide would not be appropriate, as they only detect recent smoking, for example within the last day, whereas there are at least 30 days between visits in a study such as this. As shown by Tavares et al., acrylonitrile, a tobacco smoke toxicant, is converted to 2-cyanethylene oxide in the body and can then attach to the valine terminal amino acid in hemoglobin. Specific for tobacco smoke exposure, we have employed this hemoglobin adduct, which we abbreviate to CVAL for simplicity, as a long-term biomarker of compliance in our study. Based on the erythrocyte life cycle, CVAL from cigarette smoking is detectable in the blood for approximately 90 to 120 days. And based on CVAL levels seen in our previous clinical study of a reduced toxicant prototype cigarette, we set thresholds for CVAL levels at 3 months, 6 months, and 12 months in this study. And we use these to categorize subjects in terms of their compliance with the not smoking restriction. This was pre-specified in our SAP, which has been published at the reference there on the screen. And we have a publication describing how we devised the thresholds, which is currently under consideration for publication. So if I go back to the number of subjects, the additional table at the bottom here shows the number of subjects who were CVAL compliant based on those pre-specified thresholds in the glow and cessation arms. With solus use or complete cessation in the region of 75% rate, we still meet our target number of compliant completers. So on to the results of our study. The graph on the left shows the mean 24-hour excretion at each time point of total NNAL, which is a biomarker for exposure to the carcinogen NNK. The blue line is continued smoking, orange is switch to glow, grey is cessation, and the never smokers are in yellow. And this is the full per protocol population. This is not adjusted for CVAL compliance, yet it shows a reduction from baseline for both the glow and cessation arms. The graph on the right shows those who completed the study per protocol to 6 months and includes only the CVAL compliant subjects in the glow and cessation arms. And this increases the mean reductions from baseline for both of these arms. In summary, mean NNAL substantially reduced from baseline in the glow and cessation arms, and CVAL adjusted cessation arm reached levels comparable to never smokers. Here are 2 further examples of the CVAL adjusted time course plots from our study. On the left, SPMA, a biomarker for benzene exposure, was substantially reduced from baseline in both the glow and cessation arm, reaching levels comparable to never smokers. On the right is MHBMA, a biomarker for exposure to 1,3-butadiene, which also reduced substantially from baseline in the glow and cessation arms, reaching levels again comparable to never smokers. When we looked at our 6-month data for exposure to another carcinogen, NNN, we noticed some inconsistency. For glow, the mean change from baseline at 6 months came out as an increase, which was not consistent with emissions reductions and other preclinical results. We look at the data a little deeper. There are two extreme observations of increases from baseline at 6 months of 434 and 76 nanograms per 24 hours at the 6-month time point, and these skew the mean data. Given that average NNN excretion for smokers is widely reported as being around 10 nanograms per 24 hours, these increases are inconceivable, and we hypothesize they may have arisen due to some endogenous formation of NNN within these samples. If we remove one or both of these extreme values, we see mean reductions more in line with the median reduction. Furthermore, a post-hoc sensitivity statistical analysis, removing just the one most extreme observation, points to a significant reduction in NNN exposure compared to continued smoking. This bar chart shows all of the biomarkers of exposure assessed in our study, with the average change from baseline as expressed as a percent of the average baseline value. The orange bars are the CVAL compliant glow arm, with the grey bars showing the CVAL compliant cessation arm. And nicotine equivalence here is outlined in green, as this is the marker for nicotine, which glow needs to be able to deliver to be a feasible alternative to cigarette smoking. All of the other markers are reduced from baseline between 33 and 93% for glow, and between 62 and 98% for cessation. And all markers from orthotoluidine here, onwards to the right, are reduced to a similar extent in both study arms. And this is also summarized in this table, which lists all of the biomarkers that we studied, all of the biomarkers of exposure we studied, and their associated toxicant. The classification as carcinogen, CA, respiratory toxicant, RT, cardiovascular toxicant, CT, and reproductive or developmental toxicant, RDT, comes from the FDA harmful and potentially harmful constituents list. The changes from the baseline from the bar chart on the previous slide are shown here in numbers for the glow and cessation arms, with the final column showing the absolute change for glow expressed as a percentage of the absolute change for cessation. Now for glow, the carcinogens NNK and NNN were reduced by around half as much as cessation, whereas the other carcinogens reduced to a similar degree of cessation, including the aromatic amines 4-ABP, 2-AN, and orthotoluidine, and crotonaldehyde. Also, benzene, 1,3-butadiene, and ethylene oxide, which all fall under 3 of these 4 toxicity classifications, are reduced in line with cessation. To summarize, switching to glow resulted in a statistically significant reduction in toxicant exposure compared to continued smoking. And most of these markers reach levels similar to complete cessation. This meets the standard proposed by the Institute of Medicine in their 2012 report on scientific standards for studies on MRTPs, modified risk tobacco products. The reductions in exposure were sustained for the 6-month period, and these data support the conclusion that glow is a reduced exposure tobacco product. Our findings on a range of biomarkers of potential harm included in this study will also be published. Just some acknowledgements. I'd like to thank my co-authors, and we would like to thank Covance, Richmond Pharmacology, Solarian, and Simbec for their management and conduct of the clinical phase of the study. We'd like to thank Dr. Scherer and his team at ABF for performing the bioanalysis, and Yoga Keralapura, BAT's Data Sciences Manager, for his oversight of data management. I also thank the session chairs, Professor Karetas and Dr. Poulos, for inviting me to speak, the conference hosts, organisers and committees for allowing me to do so, and I thank you all for your attention.